Hello viewers, I am Kausalya. Today we are going to solve problem related with the star and delta networks. So here the problem is the current in RY, YB and BR branches of a mesh connected system with symmetrical voltages are 20 amps at 0.8 power factor lagging and 25 amps at 0.7 leading and 20 amps at unity power factor respectively. So here the thing is it is a mesh connected system, right? That is delta. So here the current flowing in the respective branches are given here. That is current flowing in RY is 20 amps at 0.8, YB is 25 at 0.7 and BR is 25 amps at unity power factor. Right. So find the line currents assuming that the phase sequence is RYB. Right. So here we need to calculate the line currents. So what are all the line currents? The line currents are IR, IY and IB. Right. So here again the phase sequence is given, right? RYB, but here the voltage is not given. So here that is the first sequence is RY, YB and BR. So here the value of VRY is that is some voltage of value V with an angle 0 degrees. And similarly VYB is V with an angle minus 120, right? Because we all know, right, they are electrically displaced 120 degree apart. So finally VBR is V with an angle of either it may be minus 240 or it may be plus 120. Okay, they both hold the same meaning. So just here the values, okay, write down the values in the diagram they had given, right? So here the first thing is, you see, these are all the values of voltages, right? And the next thing is the current flowing through each branch is given, right? The current flowing through this part IBR, IRY and IYB, everything is given. So here we are starting with IRY. So it is 20 amps at 0.8 power factor lagging, right? So here what does it mean 0.8? That is cos pi value is 0.8. Therefore pi will be cos inverse of 0.8, right? So here it is 36.9 degree lag. Since here we are having 3 branch currents, I have taken this value of phase angle as pi 1, right? The next value of current is, you see, 25 amps at 0.7 leading. So again pi 2 is cos inverse of 0.7, so that is 45.6 degrees, right? And finally the last branch current is IBR, that is 20 amps at unity power factor. So here pi 3 is equal to cos inverse of 1, which is 0 degrees, right? So here now we have find out the values of phase currents, right? So the phase currents are 20 with an angle of minus 36.9 degrees and the next one is 25, right? So since the voltages have a phase displacement, the same way current will be having their respective displacement, right? So here again the phase difference between your IRY and IYB is, it is minus 120, right? So minus 120, but here what happens, it is a leading angle, therefore it is plus 45.6. Therefore minus 120 plus 45.6 gives you minus 74.4 degrees. And finally IBR. So here the value of IBR magnitude is 20, right? And the power factor is unity. But here it is with 20 with an angle of plus 120 degrees plus 0 degrees. So here it is 20 with an angle of 120 degrees. Right. So the next thing is, now we are going to apply Kirchhoff's current law to find the value of line currents. So here again we have to look back at the diagram. So now consider this node, right? So to this node, when you apply KCL, the sum of current flowing towards the junction. So here what are all the currents that flow towards the junction? It is IBR and IR, right? So what is the value of current that flows away from the junction? It is IRY, right? Therefore IR plus IBR is equal to IRY. So here this is your equation. So we need IR, so IR is IRY minus IBR. So here we know the values of currents, right? So just substitute the values over here, right? So IRY. So IRY is given by, you see the value of IRY is 20 amps with an angle of 36.9. Since it is lagging, here we have to write it as minus 36.9 here, right? So here this is your value of IRY and this is your value of IBR, right? So just we are converting this polar form to rectangular form and we are doing the calculation and finally it is converted into polar form, right? Similarly, IY, now the next thing is we are going to calculate IY. So again when you look at the diagram, you see where is IY? This is IY, right? So just consider this node. So here the currents flowing towards the junction are IY and IRY. And the current which flows away from the junction is IYB, right? Therefore, IY plus IRY is equal to IYB. So here when you write expression for IY, it is IYB minus IRY. So just substitute the values here. Again, each polar form is converted into rectangular coordinate and we are doing the rectangular coordinate, you can directly add or subtract, right? So here this is your answer and finally this is converted into polar form. And finally we are going to frame expression for our current IB. So again when you look at this node, right? The current flowing towards the node. What are all the currents that flow towards the node? It is IB and IYB. The current which flows away from the node is IBR. So here the expression is IB plus IYB is equal to IBR. So here again we need IB. So IB is nothing but IBR minus IYB. We know the values of IBR and IYB. So just substitute, convert it into rectangular form and again the final answer is in rectangular form here. Again convert this into polar form, right? So this problem gets over here. We will proceed with the next one. So the problem is calculate the line currents in the 3-wire star-star system, right? So here the thing is this star denotes the source and this star denotes the load. So here this is the given circuit diagram, right? So here the source is a balanced one there. So here it is star network. You see the respective phase differences, that is difference in angles. It is 0 degree, it is minus 120 and it is minus 240. And here what about the load? These are the load impedances, right? 10 plus J8, 10 plus J8 and again here also the same. You see again this is a star network, right? And this 5 minus J2, this belongs to the source impedance. Okay, source will have its own impedance, right? So this denotes the source impedance and this denotes the load impedance, right? So now the thing is we have to find the line currents. So what do you mean by line currents here? IA, IB and IC are known as the line currents, right? So here to find the value of IA. So IA is given by VAN by ZY. So here the value of, what do you mean by ZY? Here the ZY, it is nothing but the impedance value, right? So when you look at the circuit diagram, you see this impedance and this impedance are connected in series. Similarly, these two are connected in series and again these two are connected in series. So now we are going to find the impedance of a single branch. So that is denoted as ZY here. So ZY is nothing but, since impedances are in series, we can directly add. So just add them and when you convert this rectangular form to polar form, it is like this, right? Now the next thing is we are going to find the value of IA. So here IA is nothing but VAN divided by this ZY. What is the value of VAN? VAN is nothing but the voltage between your A and N terminal. So here it is 110 with an angle of 0 degrees. So just substitute the values. So 110 with 0 degree divided by this ZY. So again when you divide this, it gives an answer of 6.81 and 0. When you move this angle to the denominator, it will become minus, right? 0 minus 21.8 gives minus 21.8 degrees, right? So the next thing is, again you can use the same kind of formula to find the value of IB and IC, right? So here when you write an expression for IB, how it will be? Here IB is equal to VBN divided by ZY, because you see impedances in all the branches or YB, they remain the same, okay? They are similar. So we know the value of ZY, we know the value of BN also. So what is the value of BN here? It is 110 with an angle of minus 120, right? Similarly for IC, you can use VCN divided by ZY, right? So again, what is the value of VCN? It is nothing but 110 with an angle minus 240, right? You can solve by this method also. But here, I had adopted a simple technique. You see, as the voltage sources are in positive sequence, the line currents are also in positive sequence. That is, they are also displaced by the same angle. So here you see, IB is nothing but IA with an phase angle of minus 120 degree, right? Because you see, when you look at this diagram, the magnitude remains the same, right? 110, 110, 110. The only thing is the angle differs. So here IB can be written as IA with an angle minus 120. So what is the value of IA? You see, this is your value of IA, right? So here just write the angle, right? IA with respect to angle, and here there is minus 120. So just write minus 120. So minus 21.8 minus 120 gives you minus 141.8 degrees, right? This is your IB. Similarly, to find IC, you can write it as IA, and the displaced is, it is displaced from IA by minus 240 degrees, right? So IA with minus 240. In other words, we can write it as IA with an angle of plus 120. Okay, both are same. So now again, what is the value of IA? It is 6.81 with an angle of minus 21.8. So write it, and here it is plus 120 degrees. So plus 120, that finally gives an answer of 6.81 with an angle 98.2 degree amps. Right. So finally we have find out the values of line currents IA, IB and IC. So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.